So continuing on with our work to figure out centers. Again, we're going to play with blocks here. So I have a triangular block, another triangular block, and then this rectangular block in the back. So we have the density for A. So these are metric units. The units are in centimeters. Density of A is 0.1 kilograms per centimeter cubed. Block B, the one in the back, is 0.2. And here C is the same as block A. Now to help us out, I just put this is from a table. This block, just coming into it, you may not know where the center of the block is. But so here, for a right triangle, the center of a right triangle is 1/3 from the fat end. So here I have base, here I have height. This center would be 1/3 up relative to the height, 1/3 over relative to the base. And this is the fat end, thin, thin. So 1/3 from the fat end. So we can use that to our advantage. So once again, when we do these things, when you do them on an exam, you need to do them in a tabular form because that's the only real practical way we can keep track of your work and give you partial credit if you screw up. So if you don't make it in such a way that we can follow it easy, when we grade the exam, it's wrong. So take that to the bank. So now we need to fill out this little table. So we want to get the centers of all our parts. We have 3 parts to play with. So for part A, the X is coming down like so. Now notice that we have this 12 by 12 by 90 block in the back. So relative to X, we're offset by 12. So here's 90. Here's the fat end, as it were. 1/3 of that is 30 plus 12, 42. All right. So for part A, if we go in the Y direction, its thickness is uniform at 12. Half of that is 6. If we take this part in the Z direction, it's triangular, it's 90 high. The fat end, 30. Done. Part B, in the X, it's uniform, 12. Half of that is 6. Likewise in the Y. And then halfway up this 90 centimeter high block gives us 45. Y, relative to the X, it is uniform in thickness. That gives us a 6. Going along the Y, it's 12 plus 1/3 along the fat end, 30 is 42. And then going vertically, we have 90. 1/3 of that is 30. So now we have all the centers. So we're going to do this problem once again twice. We'll get the center of volume, and then we'll, and I'm doing this just for educational purposes. On an exam, if I said, tell me the center of mass, compute the mass for all 3 parts and just do the problem directly. You don't have to step through the volume. We're just doing both of these for educational purposes. So understand that. So we're going to do center of volume, then we'll do center of mass. But let's just finish out the table here. So I have a triangle, and the volume of a triangle is 1/2 base times height times thickness. So I have 1/2, base is 90, height is 90, thickness is 12. That works out to 48,600 centimeters squared. C is identical. So we can just appeal to symmetry and just write that answer in and be done with it. The block in the back, rectangular, is 12 by 12 by 90. That is 12,960 centimeters squared. Add them all up, you would have 110,160. All right. Now we'll just do the mass. We're going to do our centers computations separately, but let's just get the mass as long as we're here. Part A and C both have 0.1 kilogram per centimeter squared, so multiply this by part 1, and you have 4,860 kilograms. Likewise for C. Part 2 is density is 0.2, so 12,960 times 0.2 gives us 25 92 kilograms. And if you add all that up, you'd have 12,312 kilograms. Blocks for giants here. Okay. So then when we go to compute, we'll note XV by symmetry is also equal to YV. All right. So we have symmetry relative to the X and Y axis. So let's just knock that off. So relative to center of volume, you have 42. We'll do this for the X computation. 42, we have 48,600 plus 6, 12,960. Go down, take the next 6, plus 6, 48,600. Divide by the total volume, 110,160. And that equals 21.88 centimeters. I will leave you to do the computation for Z. ZV, if you follow, basically multiply these and these together, you will come up with 20.21 centimeters. So that's an exercise for you to do. XM, center of mass, which will be, relative for the X and the Y coordinate by symmetry, they will be the same. One would now do 42 times 4860 plus 6 times 2592 plus 6 times 4860. Divide by the total mass, 12,312, and one would come up with, oops, I wrote this down wrong here, excuse me. Pull this from the wrong slot. That'll be 31.76 centimeters, and XM and YM will be 20.21 centimeters. And again, I'll leave it as an exercise to you. ZM you should find is 33.16 centimeters. And that exhausts that problem. All right, now if you look at these problems, I've just been adding slight wrinkles to them. They've just been dealing with each case a little concept here and there. And we're going to add in our last complication, namely a hole. So what do we have here? I've got a block where this is a hole. All right, so here's what I'm going to do. I'm going to break this block up. So this is, what I have here, you could view this as a rectangle where I've cut off a rectangular piece, or you can view this as a square plus a triangle. There is no right answer as far as that goes. Both work. You still have two parts to deal with. And then I will subtract off, in this model, this hole. So basically you have two choices. You can view with this as a big rectangle minus this rectangle, that will be a hole, and then here we have this drilled hole, the bore. All right. I've chosen this one. So 2 positives and 1 negative. When you're going to get the center of mass, every time you have mass taken away due to something cut away or a hole, that's then negative. Anything that adds mass or volume or area, whatever your weight, whatever you're working with, that's a positive. If you're taking it away, that's a negative. So the equations work in the logical way. All right. That's fine. So now we go through. So I have a part here, and a hole there. So let's just deal with the parts, fill in the table. So this square here, it's 30 by 30. The center is 15, 15. All right. Part 2 is this triangle out here. It's offset by 30. Then it's another 30. 1/3 of that next 30 is 10. So 30 plus 10 is 40. This triangle is 30 high. 1/3 of that is 10. Done. Part 3. The center is in the middle of this square. 15, 15. All right. Areas. So we're going to treat this thing as having constant density, uniform depth. So the z is, if we make this the x and the y per usual, We're not having, all we have is area, so we'll just work on the coordinates that we have in x and y. And we presume the depth is uniform to get the center relative to z. Z divided by 2, all done, easily handled. So we're left with area. Okay, so we have 30 by 30. Well, that's 900 for the first part. Here we have 30 by 30. It's a triangle cut in half. 450. And then down here, we have a diameter of 15 centimeters, hence a radius of 7.5. So that would be pi 7.5 squared, which is 176.7 centimeters squared. So, what's the total area? 900 plus 450, and I often just put a plus sign here and a plus sign here to remind myself I'm adding, and a negative there. So that's 1350 to here minus 176.7. That leaves 1173.3 centimeters squared on the area. And now we're ready. Okay, so let's so notice here in doing the area, you have a hole. We took out area, subtracted it. Now we're going to do the center. We'll look at XA. We have no symmetry to play with, so we'll have a separate XA and YA. And we just go down for the parts. This times that, plus that times that, minus that times that, because it's a whole I'm taking away. So 15 times 900 plus 40 times 450 minus 15 times 176.7 bracket or line 173.3, and we're left with 24.59 centimeters for the x. The y, go down the line. 15 opposite 900 plus 10 times 450 minus 15 times 176.7 divide 1173.3, and we would come out with 13.08 centimeters. We are done. All right. The last thing we're going to do is we're going to take a look at one problem where we do this by integration. You're doing integration, and so the idea is we want to kind of expose you to some integration. Again, we're not going to hold you accountable for this on the exam, but we want you to appreciate it because oftentimes students will be doing something, they'll go, why are we learning this? And we have many times had math professors go, I don't know, the engineers make us teach it. So we need to show you from time to time why we make you learn what you learn. So we're going to have a little exposure here to centers via integration, and that'll finish this chapter. Talk to you soon.